Hi everyone, my name is Rahul Vishwas. I am BTech third year electrical student from IIT Bhubaneswar, and welcome to the experiment number 5 of digital signal processing. That is, we need to find the DFT, discrete Fourier transform, using fast Fourier transform FFT methods. So for that we need to first install the library Arduino.fft, and we need to include the library here, and this script will already find Arduino.fft example. There will be 5 examples, so we are taking the second example from that scripts, and we'll get that. And so now we are calling this script, then copying the script, and now this is the function x 150 samples with function with PPG signal 150 sample. And now as you have already know that the Fourier fast Fourier transform will only operate at a exponent of 2. So the next exponent greater than 150 is 256. Next exponent of 2 greater than 150 is 256. So we will take the 256 sample, and we need to add from 151 to 256 as padding 0 padding will be there between 151 to 256, and we'll store the VReal and VG imaginary separately, and we'll give this input to the inbuilt function. So for that, first we need to do the 0 padding. So here we are doing the 0 padding. For I greater than 150, y(i) is 0, and less than 150 it is y(i) equal to x of I. So 0 padding we have done, and VReal will be the y of I, VReal will be the y of I, V imaginary will be 0, because as you have seen this, all the values are real value, no imaginary value is present, so imaginary all value will be 0. So now the FFT, we have to find the FFT. So this is the FFT VReal. First we need to compute, so we need to first give the VReal will be y of I, V imaginary will be 0, and n in the number of samples, that will be 256, and here the exponent is already inbuilt, that is E. We need to also know the value of that is inbuilt function. We don't need to do anything with that. So and then we need to FFT complex to magnitude. So we need to convert complex to magnitude. We will also give the VReal, V imaginary, and n. So now float max equals to 0. So now we have to find the k value. K value will be the maximum value, where the value of the I, where the function has the maximum value. So for finding that, we are using the maximum function method. So if the VReal is greater than Vmax, then Vmax is VReal equal to, we need to set as max value, and like this we have to iterate from I equal to 1 to 256. Now I equal 1 to 1, so we have to take the first maximum value, so 128 to take, and this Imax will be the k value. So now we need to find the frequency. Frequency will be the f equals to Imax into 50 into 256 by 256, so kfs by n. And now float is pulse we have to find is equals to f into 60. So now we need to just print the pulse, check the value of the pulse. So as we need to upload it, so as you can see the uploading has already done. So now let's check the serial monitor. So this 70.31 is the period of the function that you have to calculate, we need to calculate. So this 70.31 is the actually the pulse rate of this sample. So now we need to find another. So now welcome to the second part of this experiment. So in this part we have two signals combined with each other. So we have in this x of x, we have both the signal of PPG signal along with the respiration signal. So we don't know which portion is what. So this signal contain both the portion PPG along with respiration signal, and so we need to say first. So our objective is to differentiate the respiration signal from the PPG signal and reconstruct it in time domain, discrete time domain. So for that we need to first convert these two DFT, and we need to discard some of the frequency, because we know the frequency range of the respiration signal. So we will only take that portion as our signal, as the original signal, and we have to do the inverse Fourier inverse DFT. So for that we are doing this experiment. So here our sample is this, and the float we are taking this x. Then we call the Arduino.ft, and these are the inputs. These are the things which you already get from that script. And now here is the double. We will take the V real and V imaginary of the sample. So first we need to do the zero padding because it is at 300 samples, so more than this 2 raised to exponent of 2 is 512. So we need to take that value. So we need to take zero padding from 301 to 512. We need to keep the value 0. So now here we are setting the V real and imaginary portion. So V real is this x of I, and V imaginary is 0 as usual. So and now similarly we are computing this value, V real, V imaginary, sample exponent, and complex to magnitude conversion. We are doing V real, V imaginary, sample. This all are doing, and similarly we are finding the max value and the k value. So max value is when it is greater than 0, we are setting the max value to this, and similarly we are doing, and the k value is the ith of this. So we actually need this value, not this value. So now we are taking this value and calculating the frequency and the period of this. So for this, by this we will get the period of this one. So now one thing to notice here is that as we are taking the sample from frequency range from 0.05 to 0.5, so by the formula of k fs by n we will get the k value from 2 to 20. So we are taking here only 2 to 20 and finding the maximum value in this k value. So by this we will get only the respiration signal, not the PPG signal. Respiration signal without the PPG signal. So here we will get the respiration signal only. So now we are finding the reverse Fourier transform, reverse discrete Fourier transform. So here is the value, and so these are the value reverse Fourier transform, and we are taking for j less than 15 j less than 15 value as the V real and V imaginary, and all the other value as 0. So we are computing the inverse Fourier transform. So here this function will be V reverse, FFT dot reverse, because this is FFT dot forward, that is for calculating the DFT, and this is for inverse DFT. So by this we will calculate we will get the actual the respiration signal. So now let's upload it. The uploading is done already. So now check, we have to plot the actual signal. So this will be the respiration signal, actual respiration signal without the PPG signal. And there to this is the sample 512 number of sample. So this is what about this. So we will meet again in the next video. Thank you.